An Ethernet frame is a data packet used in Ethernet networks to transmit data between devices. It is the fundamental unit of data transmission in an Ethernet network. Here is a detailed explanation of the Ethernet frame structure. 1. Preamble. The preamble is a sequence of alternating 1S and 0S that serves as a synchronization pattern. It helps the receiving device synchronize its clock with the sender's clock. 2. Start Frame Delimiter, SFD. The SFD is an 8-bit pattern that marks the beginning of the Ethernet frame. It consists of the specific bit sequence 10101011. 3. Destination MAC address. This field contains the MAC, media access control address, of the intended recipient device. The MAC address is a unique identifier assigned to each network interface. 4. Source MAC address. This field contains the MAC address of the sender device. 5. Ether type length. The ether type field identifies the protocol used in the data payload. It indicates the type of data encapsulated within the Ethernet frame. For example, it can indicate whether the payload is an IPv4 packet, an IPv6 packet, or a VLAN tag. If the field contains a value less than or equal to 1500, it indicates the length of the payload instead of the protocol. 6. Data. The data field carries the actual payload or data of the Ethernet frame. It can vary in size from 46 to 1500 bytes, excluding the header and trailer. 7. Frame check sequence, FCS. The FCS is a 32-bit field that contains a cyclic redundancy check, CRC value. It is used to detect errors in the data transmission. The receiving device calculates its own CRC value based on the received data and compares it with the FCS value. If there is a mismatch, it indicates that errors occurred during transmission. The Ethernet frame structure allows for the reliable and efficient transmission of data within Ethernet networks. It provides addressing information, source and destination MAC addresses, identifies the type of data being transmitted, and includes error detection with the CRC value. This standardized structure ensures compatibility and interoperability among different Ethernet devices and protocols.